Hello. So for the project of this course, we opted to work on the project of number theory. I am part of a team consisting of Habiba, Rajab, Emmanuel, Nassour, and myself, Rawad, Bassil. As you can see, for this project work on the platform Qt, we coded using the language C++, and we also did the UI using this platform as well. The codes will be available with our Moodle submission because we don't have time to dwell in them for this demo. So the main window is pretty basic with a bunch of push buttons. And in this demo, we're gonna cover up to 5 algorithms. In each, you can see like a small description, as well as how to use the calculator. And I will start by going into prime factorization. So here I can input any number. So let's say 7. I'm gonna get 7 to the power 1 because 7 is already prime. But if I input 25, for example, I'm gonna get 5 to the power 2, or if I go bigger, like 2048, I'm also gonna get like 2 to the power 11, and so on. I can also clear all my inputs, go back, and from here on out, Habiba will take it.
Thank you, Rawad. So now moving on to the Euler's totient function. Basically, what this function does is that it counts the positive integers up to any given integer n, and it sees what is relatively prime to it. So now we're just going to input a small integer, which is 8, for example. So if we can please input that and compute. So it gives us 4. However, if we input 2,355, basically, this is what it gives us. And now moving on to the Miller-Rabin algorithm, basically what this algorithm does is that it determines whether a given number is likely to be prime or not. So basically, let's input a prime number 101. And let's compute that over 16 rounds. It's going to be prime. However, if we input 28, for example, and compute it over 4 rounds, it's going to be composite. So now my colleague Emmanuel will be presenting the last 2 algorithms.
Thank you, Habiba. So the next algorithm is the fast exponentiation algorithm. So here we have to enter a number, its exponent, and its modulus, and we can get the result. So if we enter 8 to the power 23 modulo 15, we will get 2. And what we can also do is take out the modulus. So if we take, for example, 7 to the power 6 with no modulus, we would get the result of 7 to the 6th power. Next up is the Chinese remainder theorem. We use the Chinese remainder theorem to solve a system of linear congruences. So here, if we enter any 2 modular equations, say 1 modulo 60 and 0 mod 7, we should get 301 mod 420, so minus 119, which is the same. Now here in our GUI, we can only go up to 5 equations, but our algorithm works up to an infinite amount of equations as long as it doesn't overload. So thank you for bearing with us during this presentation. We have learned a lot while doing this project. Please like and subscribe and stay safe.
Thank you. Bye.
Bye.